So as we did last time, here it is. So the first thing you're going to do is you're going to do your 6 basic graphs on the first and the top of the second. And I'm also going to write on 2 of the basic graphs. Let me just write it on the board right now. 2 of the basic graphs, you're going to do a shift to review what we did last time. So as you go through, after you've done your basic graph of the square root, then on the square root graph, also graph the square root of x plus 7 minus 2. And then on the x cubed graph, after you've graphed that, graph x plus 2 cubed minus 1. So I'm going to give you 6 or 7 minutes to go back through, reproduce the basic graphs as best as you can, as quickly as you can, and then do the shift of those 2 right there, and then we will get started with today's stuff. Here we go. I'm just going to go through. Remember, I might get on a roll, but if you have a question, ask the question. Okay, that's why we're all together. So I'm going to go through, graph these, and if anything pops up that you'd like to know a little bit more about, then by all means, let me know. So here goes. This is the x squared graph. So remember, that means whatever x I plug in, I'm squaring. So when I go, x is 3, when I square it, I get 9. X is 2, I square it, I get 4. X is 1, gives me 1, 0, 0. When I square negative 1, I get 1. Negative 2 gives me 4, and negative 3 gives me 9. And there is my graph. Remember, these sides are not straight lines. This is a curve. It's called a parabola. Satellite dishes are in the shape of a parabola. Water fountains, when the water comes out, it's a parabola. So that's all good stuff. Moving to the side, the absolute value. The absolute value says whenever I put an x in, if that x is positive, it stays the same. If that x is negative, I make it the positive. So when I plug in positive 5, the absolute value is 5. When I plug in 3, the absolute value is 3. When I plug in 1, the absolute value is 1. 0 gives me 0. Negative 2 gives me 2. And I'm just picking different values just to show you that we don't have to get typecast and always use the same ones. Really, the only limiting factor to our values is the grid that I've given you to work with. So the absolute value, those are lines on both sides. It should look like a nice V shape. Next one is x cubed. When I put my x in, I cube it. So again, I'm limited only by my graph. So when I cube 2, I get 8. When I cube 1, I get 1. 0 gives me 0. When I cube negative 1, I get negative 1. And negative 2 gives me negative 8. So here is my cubed x cubed graph. Oh, that's lovely. Getting so much better at drawing. Then I did ask you, once you've drawn the cubed graph, to then practice our shifting, because we did translations in section 2.2. So when I shift this, what does the plus 2 inside the parentheses tell me to do? I am going to go left. I'm going in the negative x direction 2 units. And what does the negative 1 tell me to do? I'm going to go down 1. So I'm just going to take those points and I'm going to move them all left 2, down 1. So left 2, down 1, boom, left 2, down 1, left 2, down 1, left 2, down 1, and finally left 2, down 1. And so just as a reminder, when you translate a graph, it does not change the shape of that graph. It just changes its position. So you can see I've got the exact same graph there. It's just been shifted left 2, down 1. Yes?
No, we're not gonna cube the 2. Just double checking, because like my brain, I'm looking at it and I'm like, you're supposed to like cube everything like in the parentheses.
Well, if I plugged in x values, I would cube them. So notice my blue graph, the x values should agree with what's there. So at this x value right here at the origin, that x value is 0. So what do I get when I plug 0 in? Well, what's 0 plus 2? 2. What's 2 cubed? 8. And then minus 1 is 1, 2, 3, 4, 5, 6, 7. We're already there. So instead of plugging in values to get the new graph, I am translating. I'm trying to understand how these values work. So you can either do one of 2 things. You can plug values in, which is much slower, or you can remember your basic graph and do your translations from there, okay? Either one. So square root graph, whoever just walked in, there's a page right down here. Come help yourself, please. The square root graph starts its domain at 0. So I'm doing the basic graph right now. Square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So here's my basic graph right here. Once again, I did ask that we do a translated version of that graph. So the +7 does what to the graph? Left 7, because it is in there with the square root of x. And then the -2 says to go down 2. So I'm going to take all of those points on my basic graph, and I am going to shift them left 7 down 2. So left 7 down 2, left 7 down 2, left 7 down 2, and finally, last but not least, left 7 down 2. And once again, you see that my graph's shape is not changed at all, just its location has been changed. I'm going to flip the page, unless there's a question about any of those 4 basic graphs before I move on. Cube root of x. Same thing applies here as with the cubed. I'm just trying to pick values that are going to be on my graph. So I pick 8 because 8 has a nice, easy to determine cube root. The cube root of 8 is 2. The cube root of 1 is 1. The cube root of 0 is 0. The cube root of -1 is -1. And the cube root of -8 is -2. So here is there's my cube root graph. And the last one is just the identity. Whatever I put in is what I get out. So when I put in 7, I get out 7. When I put in 4, I get out 4. When I put in 1, I get out 1, 0, 0, -2, -2. It's just a line with slope 1 and y-intercept 0, and there it is. And there we go. There's our first type of translation. That's what we did in the last section. I'm going to pause our recording, and then if you have any questions from the homework, we'll take a little time to do that. So let me stop the share for just a moment, and then let me 2.3 talks about the other type of thing we can do with our graphs, the other kind of transformation, and we're going to talk about stretching our graphs. So just to be clear, our translations, they do not change the shape of the graph, they change its position. And today, when we talk about stretching and shrinking a graph, those do not change the position, they change the shape of our graph. Once again, I'm going to start with the vertical direction because it's a little more intuitive, like we started off with our translation. So once again, I'm going to ask you the same question now that I asked you last time. If I say f of x, this right here, this f of x, what value is f of x on the graph? It is the y value. So if I write something like this, c, which is just a number, okay, c means constant usually in math. If I have c times f of x, what do you think I am going to do to all the y values on the graph? I'm going to multiply by c. It's very intuitive, just like our translations where it was add to the y values and it made the graph go up, and subtract from the y values that made the graph go down. So now I'm multiplying my y values. So here's what you do. If c is bigger than 0, meaning, I'm sorry, that is a typo. It should be if c is bigger than 1. Sorry about that. Please make sure to make that correction. I'll have to go back into my file and do that same thing. If c is bigger than 1, so meaning it's a number larger than 1, 1.5, 2, 2.325, something like that. If it's anything bigger than 1, then the graph c times f of x is stretched vertically by a factor of c. So if c is greater than 1, then our graph is stretched vertically by a factor of c. Basically, that's just fancy math lingo for exactly what you told me a moment ago. When you see c times f of x, it just means you're going to multiply all the y values by whatever c is. And since c is a number bigger than 1, it's going to get bigger. So if you do the same thing, if c is between 0 and 1, meaning it's fractional, a number like a half or 2/3 or 0.1, okay, then the graph c times f of x is shrunk or compressed. By a factor of c. So basically, just like with our translations moving up and down, it just depends about what the value of c is. And once you know the value of c, you know everything that you need to know. So for instance, I'm going to do example 1 along with you. I'm just waiting for everybody to be done writing. I don't want to rush off on anybody because there's really nothing to miss here. Anybody need another moment? Are we doing all right? Okay, I'm going to press on then. So example 1, I've given you just we're going to start just some nice simple functions for our first several examples. I've given you this little wave function, has a start and a stop. And so I've given you the graph of f of x. And what we're going to do is we're going to graph 2f of x. So just like you told me, what that means is I'm going to take the y values, the f of x values, and I'm going to multiply them by 2. So I'm just going to go through, I've defined several points on here, and I'm going to multiply the y values by 2. You help me. What's the y value of this point right here that's on the left? 0. So 0 times 2 stays 0, okay? Remember, stretching does not move the graph. It changes the shape of the graph. What's the y value of this next point? 3. So when I multiply that value by 2, I get, so I'm going to make a dot at 6. I don't move the dot up 6 more. I go to the value 6. Okay, that's a distinction. Sometimes students don't grasp that right away. Okay, so instead of the y value being 3, I double it. The y value becomes 6. Okay, the next one in the middle is the origin. The y value is 0. What's the y value of this point right here? -3, so when I multiply that by 2, it becomes -6, and then the last one's 0. And now I'm just going to connect the dots. So I start at 0, and I whoop, up, down, and then back up. And so you can see what we end up with there is a nice stretched out graph. You tracking with me? Please speak up if you're not. Well, what I would like you to do then, very simple exercise. It's almost the exact same thing we just did. Example 2 says, there's f of x again. It's the same function. This time, I would like you to graph 3f of x. Gives you a little practice. I'm just going to go through this. If you have any questions about what I'm doing here, please let me know. what I'm going to go and do is just take all the y values and multiply them by 3. So again, this y value is 0, it stays 0. This y value is 3, so when I triple it, it becomes 9. So up here, this one's 0. This is -3. When I multiply that by 3, it becomes -9 and 0. And so you can see I got this lovely, hit all my points. That's beautiful. I've got that lovely stretched out graph. Are we still so far so good? All right, well, I'm just going to have you do a few more. It doesn't matter with the vertical stretching. It doesn't matter what the number in front is, whether it's a fraction like the next one or whether it is a whole number or whatever. You just multiply the y values by that coefficient in front. So for example 3, again, I've given you f of x. We're going to do one more with this function, then I'll change it up. I would like you to graph 1/2 f of x. So don't let the fact that it's a half confuse or bother you. It's just the same process we were doing. I'm going to go through each of the y values and I'm going to multiply them by 1/2 or 0.5. So again, 0 times 1/2 gives me 0. This y value is 3. When I multiply that by 1/2, I get 3/2 or 1.5 or 1.5. And you might say, well, Mr. Perkins, how do I graph that? Well, you just do the best you can. 1.5 means I'm going to go up 1, and then I'm just going to go about halfway between 1 and 2. That's the best we can do with the resolution of this graph. I would never ask you to graph something like 1.875. Can't do that with any sort of accuracy. Okay, so that's the best we can do. Yes?
So for the other one, you went up from that point. So this one, you didn't go up.
Remember, this is a great question. This is what I was talking about before. When I'm stretching, my reference is not I'm going up from the point. That's translations. Okay, when I do the translations and I go up 2 units, I start at where that point is and I go up 1, 2. When I am stretching or shrinking, this becomes the new y value. So on the previous problem, okay, this one right here, I didn't go up 9 more units. Okay, I went up to the y value 9. Okay, the y value went from 3, and when I tripled it, it became 9. So that becomes the new y value. That is not a translation. It is the stretching. Okay, so it's great. It's good to get this settled in your brain right now while we're all together. Great question. So this one, the y value was 3. When I multiply that by 1/2, it becomes 1.5. That doesn't mean I move up or any down or left or right 1.5. It means that 1.5, that is the new y value. And so I'm at 1.5. Same thing down here. This y value is -3. When I multiply that by 1/2, it becomes -1.5. -1.5 is the new y value. So here we go, -1.5. It's right about there. And then 0. And so you can see we got this cute little compressed graph just like that. Did I answer your question? Great. Good question. Thank you for asking it. Yo. No, I'm multiplying 3 by 1/2. So it's this y value is 3. So 3 times 1/2 or 0.5 becomes 3/2 or 1.5 or 1.5. So that's where my new y value is now 1.5. 1.5. The new y value is what you get when you do the multiplication. Try the next one, the half circle. The half circle is the function g of x. And now what I would like you to do is 1/3 g of x. So I'm going to take each of the y values, and there's only 3 points that I've defined on this half circle. I'm going to take each of the y values, and I'm going to multiply them by 1/3. So on this end, the y value is 0, so 0 times 1/3 stays 0. Here's the one that matters. What is this y value right here in the middle? 3. So 3 times the 1/3. 3 times 1/3 is 3/3, or 1. 1 becomes the new y value. So I'm going to have my y value right here at 1. And then this other one over here is 0. And so what we've done is we've compressed the circle, pushed it down, and it's no longer a half circle anymore. It's just all compressed. A little better? Next one, example 5. Do that half circle, that g of x. This time multiply it by 1.5. Please. So again, the endpoints, the y values are both 0. So 0 times anything is 0. The point in the middle is the one that matters. And when I multiply 3 by 1.5, what's the new y value? 4.5. So 1, 2, 3, 4 and a half. And so my new thing, there it is. One more. New function, h of x, with some extra points. Not everything is 0 on this one, so it makes it a little more fun. Multiply all the y values there by -2. We're going to talk a little bit more about negatives later in the class, but it doesn't change your process at all. What I'm going to do is multiply all of the y values of this one by -2. So this first y value over here is 1. When I multiply that by -2, it becomes -2. So I drop down 2 from the x-axis. This y value is 4. When I multiply that by -2, it becomes -8. So it comes down here. 0 stays 0. This y value is -4. When I multiply that by -2, it becomes +8. So that's the new y value. Finally, this y value is -2. When I multiply it by -2, the new y value becomes +4. So again, I've changed the shape. I'm just connecting the dots in the same order that they were connected. And you can see that the 2 part of this, multiplying by the 2, stretched the graph out. But then what did the negative do to all the values? All the positive y values became negative, and all the negative y values became, we're going to talk about that a little more, but I didn't think it was something that would be too terribly trying to introduce at this point. Before we move on to horizontal stretching and shrinking, like it's an accordion, just want to do a couple more quick examples. I'm sorry, if this was a normal semester, I would have colored pencils for you so that you could do multiple graphs. So I'm not meaning to confuse you. I just also didn't want to kill too many trees and print out like 22 pages for you. You had a little booklet today. So what we're going to do though is we're going to go back to a couple of these graphs and we're going to incorporate the translations as well. So if you do not have another color, maybe connect these with like a dotted line, or maybe you can shade it darker somehow so that you know which graph represents which when you go back and look at your notes a little bit later. So I'm just going to flip back a page. So this first graph was 2f of x. So I'm just going to, again, a nice simple first example. So in green, I'm going to do 2f of x, and then let's say -3. So remember, order of operations. When you get one of these problems and it has multiple things, stretching and translations, do your multiplication first, and what I would advise you to do is have an intermediate graph and do the multiplication and do the graph, whether it's dotted or lighter or something else, or maybe you go to Dollar Tree and get some colored pencils for $1, whatever it takes, and then do the translating from there. So if I gave you this problem on the test, 2f of x -3, maybe green isn't the best one. I don't know that you can all see that. So let me get purple here and we'll try to make this look better. There we go. So if I gave this test, or if we were doing this, what I would do first is I would do the multiplication. I would do 2f of x. And then I would be staring at what I have right here. Now I would go to the final answer. And so what does this -3, this is from last time, what does this -3 do to that graph? Down 3. We are subtracting 3 from all the y values. So I'm going to take this, because it's outside the function notation, I'm going to take this and it's going to go down 3. On the next one that you did, we'll solve that because some of you were pointing left or right. So there's a difference. Remember, this -3 is outside. If I had written this 3f of x, whoops, that's terrible. I don't even know what I'm writing there. 3f of x -3. If I put the -3 inside the parentheses, that's different, remember. And you'll do that one in just a minute. So this says move the whole thing down 3. So I'm going to take that orange graph and I'm just going to move the points down 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and last but not least, 1, 2, 3. And so remember, translations do not affect the shape, so it stays stretched out. But what I've done is it has now moved down 3 units. Now, just as cause for review on this first one, when the -3 is inside the parentheses connected to the x, what does that do to the graph? Right 3, exactly, perfect. So what I would like you to do, I'm going to write this right here. Ooh, purple is the color of the day. So we're going to move this right 3. So you're going to take that, on my graph, it's green. You're going to take that stretched out graph and you're going to move it right 3, please. I'm just going to go through the stretched out graph. I'm going to move each of those points right 3. So 1, 2, 3 there, and then 1, 2, 3 right there. And then the origin 1, 2, 3, the low point 1, 2, 3, and then 1, 2, 3. And again, the translation part of this does not affect the shape. Oops, I'm going to miss that point. Sorry. Worst graph of the day. One more, just to make sure we're feeling okay. What we're going to do is we're going to take this, this graph, the half circle that we stretched by a factor of 1.5. And what I would like you to do is do 1.5. Let's just go g of x, and then let's go plus 2. I'm just going to take the 3 points here and I'm going to move them up 2. That's what this plus 2, it's outside the function notation. It means move it up 2. So here goes, up 2. This is 4.5, so 5.5, 6.5, up 2, and then up 2. So there is my graph. So we're just combining the different things. All right, so the other big thing today, we are going to address the negatives in a little more detail, but the other big thing is, okay, you've showed me in detail, Mr. Perkins, how to stretch it vertically in the y direction. Can we do the same thing in the x direction? And yes, the one caution is the same caution I gave you about translations. And we saw this just a moment ago. We were reminded of it on this problem right here when I said f of x minus 3. And again, I totally get it. It's hard. This is hard at first to see. The x minus 3, your brain automatically says, I'm going in the negative direction, it's a minus. But no, you have to relearn and say x minus 3 means go right, means go in the positive direction 3. The same is true for my stretching and shrinking. Whoops, going in the wrong direction on my notes. So if c is bigger than 0, then f of cx. So notice now, as you're writing, that the c is inside, attached directly to the x. Here's the only thing you have to remember, and it's the same thing as for the translations. This does not mean multiply all the x's by c. It's the reverse. So what you're going to do, then f of c of x is vertical, excuse me, it is not, it is horizontal, shrinking by a factor of, and here's the key, and you remember this for both the stretching and the shrinking, by a factor of 1 over c, meaning 1 over c, I'm just going to tell you the fancy word for that, that's the reciprocal. So all this means, that's the fancy math lingo, all this means is you multiply the x's by not c, but by 1 over c. Okay. And also, because I just copied and pasted, this shouldn't be c is greater than 0. That should be c is greater than 1. Sorry for my bumbling nature. So if c is a fraction between 0 and 1, then f of cx is horizontal stretching by a factor of 1 over c. Once again, I know that that's the fun math definition that you read in the book. I'm just giving that to you so you see it. All you need to remember is when the c is attached to the x, you multiply by the reciprocal. And the stretching and the shrinking is going to work itself out. Just giving you a moment to copy that down. And then we're going to go through some examples like we just did for the vertical. So here goes. So here's my function f. It's the same function f we were using a little while ago, just a few points. Now I've got f of 1/2 x. Well, let's just be careful to write this down because I know when we're doing things horizontally, it's a little goofier. So 1/2 x. What am I going to multiply all the x's by? Okay, a better pen is necessary. There we go. Yes, those of you who said 2 over 1, you're 100% right. You multiply by the reciprocal. It's always the reciprocal. That's what in this definition that I just wrote, by a factor of 1 over c, that's the reciprocal of whatever c is. So I put a 1/2 in front of the x, so that means multiply the x's by 2. It's the reverse, and I understand that is awkward. It's not the way I would have designed math if I was the creator of the universe, but unfortunately that was not my job. Okay, so we have to just deal with it. So I'm going to go through all the x's and I'm going to multiply them by 2 over 1. So here goes. This x value of the leftmost point is -4. So when I multiply that by 2 over 1, it becomes -8. So just like before, that is the new x value. So -8. This x value is -2. So when I multiply that by 2 over 1, it becomes -4. So the new x value is -4. The origin stays the origin because the x value is 0. This x value is +2. So when I multiply it by 2 over 1, it becomes 4. So the x value is 4. Notice we're not doing anything to the y values. Then just as a little aside, in this class, you will either just to keep things more sane for all of you, you'll either do vertical stretching or shrinking or horizontal stretching or shrinking. I'm not going to ask you to do both. I believe I deleted the homework problems that both happen, and it's not going to be on the test. You only need to stretch and shrink one or the other. Now, translations, we're going all over the place. Okay, just the stretching and shrinking because I know it gets complicated. Okay, and then this last x value is 4. When I multiply that by 2 over 1, the new x value becomes 8. And so you can see, inside the x, it says half x. That stretched the graph out by, oh, I totally missed that point. Stretched the graph out by a factor of 2 over 1, or it doubled the length of the graph. Yo.
So now that you said that either is shrinking or stretching, when will we know if it's shrinking or stretching?
Well,
Like, is there a key?
to be honest with you, when I learned it and what I'm advocating is just let the graph determine if it's stretching or shrinking. Just do the points, multiply by the reciprocal. But you know it's stretching or shrinking when you do the reciprocal. When I did the reciprocal of a half, it became 2. So I multiply all the x's by 2. What's that going to do? It's going to make them all bigger. That's stretching. If I did the reciprocal and it's a number less than 1, which you will do in example 9 in just a few minutes, the reciprocal of that is going to be a fraction. That's going to shrink all the x's. So it's going to be shrinking. You'll get the hang of it when you do some problems. That's why I'm not recommending memorizing that. I'm recommending do some of these and then it'll begin to click. Oh, okay, I see what's going on here. So try the next one, example 8. And I know the points are going to go a little off the graph. Just do your best guesstimate left and right on that problem, please. I'm not going to graph it yet. I just want to give everybody a nudge, make sure we're going the right direction here. So I've got a 1/3 in here in front of the x. So that means realistically, I'm going to multiply the x's by what? The reciprocal, which is 3. Yes, so multiply all the x's by 3. Perfect. And then Clarissa or Clarissa? Clarissa, just like you said now, or you were looking at, since you're multiplying by 3, that means all the x's are going to get bigger, and I'm stretching it out. Okay, great questions. You guys are doing really great with your questions today. I appreciate it. Helps me be a better instructor when you ask questions. All right, here goes. This first x value is -4. When I multiply that by 3, it becomes -12. So here's 10, 11. I'm just going to guesstimate that -12 is right about there. This is -2. So when I multiply that by 3, it becomes -6. 0 stays 0. This is 2. When I multiply that by 3, it becomes 6. And then this is 4. When I multiply that by 3, it becomes 12. So 10, 11, 12, something thereabouts. We're just sketching, so it doesn't have to be absolutely perfect. Okay, so there we go. Any questions? We're doing okay. All right, the next one. Here is g of x, the half circle again. So I'm just going to give you the nudge to begin with before we get started with this problem. So this time I've got a 2 in front of the x. So that means I'm going to give you 10 seconds to write this down. Don't scream out the answer. We're going to multiply the x's by, write down what you think. Okay, what are we going to multiply all the x values by, given that I've got a 2 in front of the x? And we're going to multiply the x values by a half, the reciprocal. Okay, the reciprocal of 2 is 1/2. So go through and do that, please. Multiply all those x values. There's 3 good ones right there. Multiply the x values by a half. first x value on the left is 3, or excuse me, it is not, it's negative 3. So when I multiply negative 3 by a half, I get negative 1.5. So my new x value is negative 1.5 right there. What's the x value of this middle point? 0. Okay, I just want to make sure we're looking at the right value. The x value is 0, so it's going to stay 0. And then the x value here is 3. So when I multiply that by a half, I get 1.5 again. So since the reciprocal of 2 was a number between 0 and 1, it shrunk all the x values, so I had horizontal shrinking. One more. Example 10. Just to give everybody a nudge, there's a 2/3 in front of the x, so that means we're multiplying all the x's by what? 3 over 2, or in other words, 1.5 if you prefer decimals, yes. I'm just going to get started doing this. Keep working if you're still working. I'm multiplying the x's, not the y's, just the x's, by 1.5. So this x is negative 4. When I multiply that one by 1.5, it becomes negative 6. If my arithmetic is wrong, don't be afraid to correct me. This x value is negative 2. When I multiply that by 1.5, it becomes negative 3. 0 stays 0. This is 2. When I multiply that by 1.5, it becomes 3. And then this is 4. When I multiply that by 1.5, it becomes 6. And you can see that that stretches the graph out just a little bit. We're going to do one more thing before we turn the page, and then we begin the homeward stretch to the end of our material for the day. What we're going to do here is this example 10. So again, if you have more than one thing going on, do the multiplication first, which we did. So then from there, I want you to please graph h of 2/3 x, and then go, let's go plus 6, just to get it out in the open. That's a 2/3, even though I wrote it extremely messily. You deserve better, I'm sorry. So it's just the function that we just did, the h of 2/3 x, then plus 6. So your job now is, what does that plus 6 do to the stretched out graph that we just completed? What does the plus 6, given its position, what does the plus 6 do to this graph? It's going to go up 6 units. Yes, since it is outside the parentheses, it's taking all the y values up 6. So this y value goes from 1, goes up to 7. This y value goes from 4, goes up to 10. 0 goes up to 6. -4 goes up to 2. And then -2 goes up to 4. And there is my beautiful stretched and translated graph. Okay?
If the 6 would have been inside, so it would have been 2/3 x plus 6, it would have made 11.
Okay, so that's a little more complicated, and I don't intend to press that issue just now, because while this doesn't happen to the y's, it didn't happen before. So the question is, if Mr. Perkins, if it had been, and you don't have to write this down, if it had been h of 2/3 x plus 6, this becomes a little more complicated, because what you have to do is a little factoring, because this, so let me change, instead of a 2/3, let me change it to a different number like 2. So if this was h of 2x plus 6, what I would have to do, I can see that it stretches all the values out by a factor of 2, but the 2 also affects the 6, since they're both inside the parentheses. So what you would have to do, and this is more of a pre-calculus problem, that's why we don't really do much of it in here. I would have to factor the 2 out and have x plus 3. And so now there's my factor of 2. I would still be multiplying all the x's by a half, but then I wouldn't be taking everything to the left 6 units. I'd be taking everything to the left 3 units. Okay, so it's a little more complicated than that, but you have the essence of it. Yes. Okay, great question. Love it. But don't worry about that right now. That's not my intent. Okay, if there's something stretching going on the x direction, we're going to kind of just leave that alone for now. Okay, so next page. We kind of touched on this on our first page when we were talking about the vertical stretching and shrinking, and the last one I asked you to do was to multiply all the y values by -2. And then I followed up with the question, that negative, what did that negative do? Well, the negative took all the positive y values and made them negative, and all the negatives and made them positive. So we're just going to look at the graph, and I'm going to tell you what this does, and we're going to write it out. So on this one, if I have a negative in front of the f of x, it just means multiply all the y values by negative. We're doing absolutely nothing different than we did before. Okay, so there's nothing new going on here. I'm just pointing out something special to you that happens. So I'm going to take the y values, and there's only a couple that this affects. This y value here at the top is 3, so it becomes -3. And this y value here at the minimum point is -3, so it becomes +3. And so we can see that all the y values get switched. So what this is called, I'm going to slide this up a little bit. I'm going to keep the graph right there for you. When the negative is in front of the f of x, what this results in is a reflection about the x-axis. Meaning it takes all the y values above the x-axis and puts them below, and it takes all the y values below and brings them up. So it's a reflection. So you can see, mine's purple, you can see that I have the exact same thing above the axis as I have below the axis. It mirrors, it's a mirror now. I should have picked a better graph, so I apologize. I thought of this later after I made the copies. So again, I did not want to kill the trees. Both of these are going to look the same, so that's my fault. I should have picked a graph that had different points. But now, when the negative is inside on the x, well, again, I'm just going to show you the way we've been doing it. We're not doing anything different than we were before. We're going to multiply the x's by, what's the reciprocal of -1? Reciprocal means we flip it. We don't change the sign. That's called the opposite. So what's the reciprocal of -1? It's just going to be -1. When you flip -1, oops, the reciprocal, can you see that? Oops, I don't even know what I'm spelling there. There we go, it needed a C. So if I have -1 over 1, the reciprocal becomes 1 over -1, which is still just -1. The reciprocal means flip the number. So we're still multiplying by the reciprocal, which is just -1. I'm just trying to show you that these examples are not doing anything different than before. There's no new learning here. Just trying to point out to you what's going on. So this means I'm going to multiply all the x's by -1. So this x right here, that's -4, becomes +4. This x right here, that's -2, becomes +2. 0 stays 0. This x that's this x that's +2 becomes negative, and this x that's +4 becomes negative. And so this time we flip all the x's. And again, I'm sorry, I should have picked a different graph. I'll know better for next semester, but that doesn't help you now. Okay, so what this does, and I'm just going to write it up here, this changes the sign of all the x values. And here's the point to this. The purpose is when you change the sign of all the x values and you take all the positive x values and make them negative, and all the negative x values and make them positive, that's a reflection about which axis? The y-axis. Yes, that was what I was intending to show, but I did not do the best job. So here's the graph again, trying to make sure everything you can see. But there's that bar. I don't know why that's there. Okay, there we go. It says, my little note up there says changes the sign of all the x values, in case you hadn't seen that. All right, we're almost done. We've got 9 more minutes. I know this class just breezes right by for me too. And then I think we've got 6 examples if we get to them all. And these last 6 examples are just combining the different things we've done. So here's what I would like you to do. I'm going to give you a minute to do it. This graph right here, I want you to do negative f of x plus 2, but here's what I want you to do. Do it in phases. Okay? I do not expect you to be able to do all of this at once at this point, if ever. Okay? So first thing you should do is the multiplication. Do a little intermediate graph, maybe dotted, maybe make it real light, of the negative f of x. Do the multiplication part. And then do the plus 2 after that. Okay, so give it a try. So when the number's on the outside, whether it's a negative or a positive, we multiply the y's because f of x means the y value. Yes, good question. So here goes. If you're not quite done, that's okay. I'm just trying to keep us moving forward. So the first thing I'm going to do is in pencil, just so it's a little lighter, I'm going to do the negative f of x, meaning I'm going to multiply all the y's by a negative. So, and if you can do this real quick, that's great. The more you do these, the better you're going to get at it. It's just the way it works. So I'm going to take this x value stays, or excuse me, this y value stays 0. This y value becomes -3. This one stays 0. This one becomes +3, stays 0. So here is my negative in pencil. Okay, my negative f of x. And now what does this plus 2 do to all those values of the graph that I just have in pencil? Up 2. It's outside of the function. It affects the y values, so I move everything up 2. So this endpoint goes up 2. This point goes up 2. I'm doing this to the graph that's in pencil. Okay, that's my intermediate step. And so here's what I've got. Next one, example 14. It's the same sort of thing. It's just not a negative. It's 2 times g of x plus 4. So once again, somehow lighter to distinguish it, do the 2 times g of x graph first. And then once you've done that, determine what does that plus 4 do to the graph. So do it in phases. So the 2, since it's outside the function, the 2 says multiply all the y values by 2. So it only affects one of them. This y value is 0, stays 0. This y value is 2 when I multiply it, excuse me, this y value is 3. When I multiply it by 2, it becomes 6. And this one stays 0. So here's my intermediate graph in pencil, so it stays light and doesn't distract me too much. That's 2 times g of x. And then in this case, since the plus 4 is inside with the x, what does the plus 4 do this time? Left 4, yes. Remember, when it's inside with the x, it's affecting the x direction, whether it's shrinking or stretching or translating. When it's inside those parentheses, it's affecting the x. When it's outside the parentheses, it's affecting the y's. So I'm going to move everything left 4. So 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So the translation does not affect the shape. The translation affects the position. Got a question? Doing all right? Okay. Flip the page. Now we're just going to some of our basic functions. So if you need to do a first sketch of the basic function, I get it. You're still learning this. But what I would do if I were you is this. The first thing is forget the plus 2 minus 4 in your first step on this one. Do the negative absolute value. Okay, what does that negative do to the absolute value graph? If you need to look on your front page where we've already done the absolute value, or if you want to do the absolute value again here, go for it. Then after you've done the negative absolute value, then tell me what the plus 2 and the minus 4 do to that graph. All right, so the absolute value graph, I just did dotted and tried to do it light. I wanted to have a reference point so you could see it, but I'm trying not to clutter up these graphs too much. I know that you can go blind pretty quickly looking at all these things. So the first thing I'm going to do, this is my basic absolute value graph. You did this on the first page in our first couple minutes of class. First thing I'm going to do is the negative. The negative is outside the absolute value. So the negative says take all the y values and make them opposite. So I'm going to do that. All these y values that are above the axis are now going to be below. So instead of 5, it's going to be -5. Instead of 4, it's going to be -4. Instead of 2, -2. Instead of 1, -1. 0 stays 0. Instead of 1, becomes -1. Instead of 3, becomes -3. Instead of 5, becomes -5. And so I'm gonna outline this one so you can see it. That's the negative absolute value graph. I'll label it so that when you look at your notes later, that's the negative absolute value of X graph. And now what I'm going to do is I'm going to follow the rest of the instructions. So what does the +2 tell me to do to that negative graph? Okay, that says go left 2. What does the -4 say to do? Down 4. So I'm going to take all of those points and I'm going to go left 2 and down 4. So left 2, down 4. 1, 2, 3, 4. Left 2, down 4. Left 2, down 4. Vertex, left 2, down 4. Here we go. Left 2. I'm having a great time. I hope you're having a great time too. Left 2, down 4. Left 2, down 1, 2, 3, 4. And one more time just because it's there. Left 2, 1, 2, 3, 4. There we go. And here's my absolute value graph. Okay, just since we're out of time, what I would like you to do, please, is make examples 16, 17, and 18. Make that part of your homework. I'll post the answers first thing at the beginning of the class on Wednesday. So if you have a question about how I got the graph, then you can ask it right away. Other than that, I hope you have an amazing rest of your day. It was good to see you. Remember to take those quizzes.